And there's entire products like SageMaker HyperPod was built specifically to have a, a standby, like a warm standby of GPUs that have been pre-warmed up that can be swapped in. That's the whole premise of the product.
First of all, congrats on the book. I think that's a huge accomplishment, and I want to dive all into everything about creating it and what you learned along the way, what you've been up to since. There is a GitHub repo that comes along with the book, which is super cool. So if folks want to get hands-on, we're also going to go fairly low level. This is something that I'm excited about because of the depth at which you bring, and then being able to kind of traverse the whole stack up and down from the kernel to the applications. And you had asked me right before we hit record, like, what do you think about the whole narrative of not wanting software engineers? So maybe we start with that, because I have some interesting takes, which is more along the lines of the applications right now. A lot of them are becoming very throwaway, and you can like think of it as akin to fast food apps, where you build it, you take some time, maybe it's 20 minutes, maybe it's 2 hours. It's for a very specific use case, and you never have to productionize that. So you don't have to think about the million things that come with production, because it's just built for you.
Yeah, I guess, coming from a large scale application, background, places like Netflix and, Databricks, and of course, most recently AWS, and, various startups in between. I think about statements like that, and the first thing that I think of is this person has no idea what it takes to maintain and run an application. Now,
Yeah.
if you're limiting it to just yourself, or maybe 5 or 6 people, right? But actually, I'm curious, continuing your thoughts there, where would you deploy it? Just out of curiosity, like a Vercel or like a,
Yeah, Vercel, Railway, but even a lot of the
Railway.
stuff that I'm running, I'm just running locally.
Yeah, yeah,
So there is no deploy in that
got
sense,
it.
right?
And then you're still using a database though, right? I assume like a Supabase or
Sometimes.
something. Okay.
Yeah, like I'm as hacky as just using Notion for my database, which is, it sounds horrible. It definitely defies all laws of everything that you would think. But it's like, oh, well, if I just want, like, for example, I'll give you the exact toy that I was playing with and building today. I kept getting sick of creating deep research reports and then wanting more information on just a piece of the report. And so I created a little bot that I can bring into the Google Docs, and then I can tag at AI and say, ask it questions, or tell it to like note this down and put it in my Notion database, whatever.
Hmm.
And it does that. And that's just for me. Like, I don't want anybody else
Yeah.
to have access to that.
And as your workflows change and as your frustrations mount, you will chip away at that. And
Exactly.
so being a little bit old school in, traditional software scaling distributed systems, I guess that doesn't really matter, right? Like, yeah, some of those things don't matter. I mean, there's like backups, and I was watching a podcaster, Matt Berman, who I'm sure you're, like familiar with. He was describing his whole workflow, and you know, um, and one of the things I noticed is he was backing everything up to GitHub, and then he had these cron jobs on top of cron jobs that were doing backups on top of backups, and it's like, well, what if the one backup cron job fails and it doesn't run till the next day? Now you're so there's a lot of hackiness going on, of course, but
Exactly.
if it works for you and you can move quickly too, and I guess you're not waiting on someone else to release the feature or Google Docs to implement it, or
That's the beauty. That is really the beauty of it. And so going back to the original idea of like, oh, are we going to need software engineers? I still am 100% convinced that we're going to need software engineers, because me doing that is nothing like me taking something and bringing it to production. And I understand that gap. What I think is just different is now how custom we are able to quickly spin things up. And also what you were talking about too with like, maintaining software is kind of a pain. 100% agree. And I don't want to now have 50 or 100 or 200 different personalized apps that I have to maintain. I get the feeling that it's probably faster for me to just start from scratch
Start scratch.
again next
Yeah.
time
Uh-huh.
than have to maintain it.
Yeah. Yeah, 100%. I was working on a project over the holidays. I, picked up for like a buddy of mine, and he's a CEO and runs a, pretty tight ship, and he's got like really good revenues, and he keeps his expenses low, um and he was mortified when during one of our stand-ups I said, "Yeah, I just threw everything away that I'd been working on for the last 2 weeks, and I started over." And it actually, um we had to talk about it offline. Like, I didn't realize he wanted me to also kind of share information with his team on my workflows. And I had already gotten to the point that, like you just mentioned, which is I could start over, and it's actually faster and cleaner, and it doesn't have to maintain all the old tests. It's just going to write new tests. And so I think we're in this shift. Yeah, curious. Do you read all of the code that's being
No,
generated?
I
Yeah,
don't read any of it,
yeah.
to be honest.
No,
Well, I mean, occasionally I'll jump in and try to read and figure out what's going on, but honestly, if I have a problem or if I'm debugging stuff, first of all, there's some awesome skills that are just open repos on GitHub, and one of them is like a debugger skill, agents, by ODA. I was checking it out a few days ago and I got it, and since then, I haven't had to use my other trick, which is using the playground skill to create a visual diagram of what's going on with the code and then help me debug
oh,
it. And
interesting. Okay.
yeah, that was awesome, and that was my go-to, because then I could isolate, like, what's the problem, what is happening, and kind of explain it in a diagram, and then the prompt would just be there in the playground. So my thing was, I would say, create a playground skill to help me debug the data flow of this app or something
Yeah,
like that,
yeah,
or all the possible scenarios of why this isn't working. And then it would have the debug prompt that I could just copy paste back into when I would isolate the issue. It's like, oh, this part of the app is not rendering this part, this button is not clicking through or whatever. Then boom, it just helps me
yeah.
transfer that.
I actually didn't even know about that. I was having it generate mermaid diagrams
Yeah.
and, generate Markdown, but all right, I have to go look into these. And these are skills for, like, Codex or for Claude or right?
Yep. Yep.
Gotcha.
And it's so nice. I feel like the playground skill is a skill that keeps on giving. Anything I throw at it, I can try and get it to do stuff. Like the other day, I was creating a horsey ranch game with my daughter to try and teach her a little bit of geometry. And we
Oh,
wanted to
fun.
change the appearance of some of the game characters. And I would say like the playground skill is really something for when you want a little more fine-grained ability than words can offer you. So that means you don't wanna have to explain things with more intensity in words. You just wanna have a slider that you can jack up the intensity or bring it down with? And so with the appearance of these different game characters, we were able to change the colors and change the size of their clothes or the
Oh,
size of their
fun.
eyes,
Yeah,
that type of stuff.
and it works with it just figures it out? It just
Yeah,
works, huh?
it's amazing how well it figures it out too, like,
Yeah.
throwing some random stuff at it, and it is wow. Yeah.
Any
impressive.
yeah, any tips for educational things for like I have two nephews and all they do is play like Roblox all day and they haven't made the, transition. My sister doesn't let me force them to learn, computer science and things. So I'm trying to do subtle ways, but like I think I've heard one of the tips is like you can, you know, have ChatGPT or Claude like ask questions back. So when they ask a question about something to research, coming back have had it ask questions. Any other thing like that?
What I've started doing with my daughter on the way to school sometimes is we will put it on voice mode, and then, I'll say, "Hey, we're trying to learn about geometry,
Right, right.
and I'm with my 7-year-old daughter, and she really likes horses. Can we can you tell us a story that, like, incorporates the diameter and the radius
Oh,
and all
cool.
that?"
Yeah.
So that's fun. Another one is trying to, yeah, create this Horsey Ranch game, which she loves, and we plugged in a voice agent too, so she can talk back and forth to it. And that is really cool because it's just so easy. It's ridiculously easy to build these things, but then sometimes I'm so out of my depth and it's like, "Oh, we hit a bug and this isn't rendering," and I don't know what's the problem, and so then I have to sit there for 30 minutes trying to debug, and my daughter gets bored and she's long gone, you know?
She's gone.
Yeah.
Hilarious.
But, dude, talk to me about this book because there's that Venn diagram or that triangle of skills that you now need, and maybe give an overview of the book that you wrote, and what kind of inspired you to write it, maybe?
Yeah. I mean, this is the third book I've written with the O'Reilly folks. And each of them, the common theme was I was trying to, um, learn as much as I could about a particular domain. So I joined Amazon, what was it, 2019. And I was came through an acquisition. I had a startup that was doing inference, very much like a base 10 today or like a Together AI or a
Wow,
Fireworks.
before
Um,
your time. A little
yeah,
before your time, huh?
it was, before like LLMs. So
Yeah.
like you can imagine it was TensorFlow models. PyTorch wasn't even big, back in 2016. Like
Yeah.
we had one PyTorch customer and they were the annoying one that we didn't know anything about. Like we would help them, but they had to do everything on their own. We just gave them our, product and they could fit
Wow.
it in. But yeah, the startup was interesting. So I had originally started at Netflix when I moved to the Bay Area. I'm from Chicago, but moved to the Bay Area to get a lot of scale. My buddy recruited me there. Very quickly realized that my little financial apps and toy apps that I was building for companies in Chicago are very different than 300 million customer, hundreds of thousands of streaming servers. So I joined the first streaming team. I was on the streaming team from the beginning. That's when they split off DVD, and so I never had anything to do with the DVD side. I was always streaming, and then um, did that, and then I joined Databricks, and I got to see data at scale. You know, that's where I met Holden Corral, who I think you know, and right,
Yeah.
yeah. So she's she kind of turned me on to the book bug,
Writing.
and
Yeah.
yeah, and I had always wanted to write a book. I submitted about 7 or 8 proposals to the O'Reilly folks. I always got rejected. Yeah, even with Holden's help and with other people's help. So they're very selective. What's interesting about the book proposal process, it's very much like when you're pitching your startup to VCs. And so it was not coincidence that I had to pitch to VCs with my startup and then, eventually sold to like Amazon. And then when I went to write the most successful book proposal, I basically followed the 12, 13 slide Sequoia, pitch deck, which I had used for all my pitches. And because what they want to know is, why now, right? Like, why is this book relevant now? Why, um, yeah, why me? Like, why am I the right, like, author for it? And they want to know competitors. They want to know the TAM. Yeah, like, what's the addressable market for this book, right? And so, um, yeah, and if you ever do want to write a book, for you or for your like audience with O'Reilly, they, give you the proposal and you have to kind of fill it out, and it's super annoying, just like filling out a the pitch deck is, and then you have to
Yeah.
pitch it to them, right? So by the third book, they were like, okay, yeah, just like give us everything, because I had done it so many times. But oh, back to this. So there's always this thing of there's so much material and I'm getting it from 100 different sources. Like the most recent book, the AI Systems Performance Engineering book, I was pulling tips off of Twitter,
Wow.
yeah, X, and I was getting tips out of, Discord channels, which like Discord scares me. I don't like Discord. Like it doesn't make any sense to me, right?
Yeah.
So, and I can't copy and paste or something out of there's something weird. So I have to do screenshots, and
Yeah.
it's very strange land over there. But and so once you realize this, and Nvidia is not really known for their documentation, right?
No.
And it is really, really bad. And when you finally land on something that explains the hardware, it's in the context of some super obscure, fluid dynamic algorithm that kind of has some similarities to what an LLM could do, but really has nothing to do. So this was my attempt to really bring together PyTorch, framework, CUDA, which is always kind of an elite type of technology and framework to learn, and then the hardware and the algorithms. So really it's hardware, it's the software, and then it's algorithms. And that's called co-design. So those three together, yeah, that's what this book focuses on. Yep.
It feels like you're doing God's work because there's like 100 people in the world that understand those 3 things that you just
Yeah.
mapped out.
Yeah, and my goal was to make that, 100,000, 1
Yeah.
million people, right? And do it in in a domain that is relevant today, because I start reading these CUDA books, and by the end of it, I can do some
You're asleep.
crazy, numerical, yeah, optimization, thing that I can't make that connection into the PyTorch world and stuff. And so,
Ah, I see where you're going. Yeah,
yeah,
because it's just so far in left field. They're like, how does this relate to the whole world of LLMs and machine learning?
yeah. And while writing the book, I recognized quickly that it's a cultural thing within NVIDIA. And hot take, no one from NVIDIA was allowed to be a formal reviewer on my book. Like, right, like let alone co-author. But that was already ruled out quickly when I had approached a couple friends of mine. They were not willing to give quotes. They were not willing to be associated. Now, that said, they were super curious and they helped me quite a bit. And they were able to, unlock a few concepts that to me weren't jiving, that I couldn't get from the forums. And unfortunately, I can't thank those people publicly. So I've had to thank them privately. And that's a bummer. Yeah, that's a real
Well,
bummer.
it's funny you mentioned that because my buddy and past co-host of this here podcast, David Aponte, he's been working on a lot of real small he's trying to figure out all of the different chips, not just the Nvidia ones,
Yeah,
but one thing he said to me in passing that it has stuck with me since is he was like, "Yeah, so Nvidia chips, they don't come with like a user manual on how they are built.
right, right.
Nobody knows what's going on behind the veil."
Yeah. And that was the DeepSeek moment, right? that was one of the, and my book starts off that way. Like chapter 1, I kind of explain, like why now, basically. Like why did and there's a lot of DeepSeek references throughout, right? Like knowing that there's going to be the next version of DeepSeek and all that. So like I'm not trying to be on the cutting edge, right? This book took a year and there was like 9 models that surpassed DeepSeek in that time. But what was interesting about the DeepSeek moment is it made people realize that even with hardware constraint, Chinese export like restrictions, DeepSeek was somehow able to basically reverse engineer some lesser documented, yeah, right. Like the Nvidia folks are like very, careful to say, no, this was a documented feature. It's just we didn't make it easy for you to find the docs, basically,
Yeah.
right? And so they like, yeah, one of the many like innovations out of DeepSeek was that they found instructions that were not well documented that could, bypass the L2 cache under certain circumstances. And of course, the Nvidia folks that are optimizing for other use cases, they would never think to do this. And so that's why it's not like a first class like CUDA API. But if you know what you're doing, you could drop down basically to the assembly, and it's called PTX, or it's it's PTX for the acronym, but they call it PTEX. Yeah, the Nvidia folks call it PTEX, so you have to be able to like translate that. So yeah, we have GTC coming up. Are you coming to that conference, by the way?
No, but
Oh man,
man,
that's
that
my
is
favorite one of the year.
yeah,
Yep.
that is a wild one. I've heard very good things about it. We
Yeah.
have some half off, I think, tickets for the community. And one thing that is pretty much impossible to get is free tickets to that.
Oh yeah. No, not unless you're speaking. Right.
Yep.
Yeah.
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 Did
I spoke a
and
bunch of years ago.
oh, nice. I was gonna ask you more about just like diving into the book and other sections of it. What were some pieces that for you, you feel like, okay, this was, as you said, challenging to put two and two together to figure out how they coexist, but now that you have it, it's like shining a light on something that was very in the dark.
Yeah, and the book takes very much like a bottoms up approach, right? So there's the sort of intro chapter to explain kind of the context of the book and what we're gonna, like some of the key terms. Like one term that is related to the hardware software algorithms trifecta, if you will, Venn diagram, if you will, is the term mechanical sympathy. And this is a term that actually I think came about from the Java world, even it was a term that references the fact that if you're going to be a really good developer, you have to understand like the environment. And in the Java context, that's really understanding the JVM, right? In a C++ CUDA context, that's understanding the hardware, the GPU hardware, because there's every generation is more than just an incremental or even like a doubling of power. There's one thing I realized when I was diving deep is that the NVIDIA folks are really good about working with the researchers to figure out what they can abstract away into the hardware. And of course, they're thinking about it at a much, much deeper level, than when you abstract things at a software level, right? Software, we're trying to abstract like the database, we're trying to abstract like the like distributed systems, yeah, companies like Temporal, for example, they're trying to abstract away retries and all the distributed systems pain. But at the hardware level, implementing operations that are common for the transformer, right? Like softmax, um, you know, and so when they work with the researchers, hopefully they're able to get down to the level of, okay, you're trying to do this within PyTorch. What can we do to the hardware to make it better for you for the next generation? That was a big unlock for me because I always, in my head, I still picture Nvidia as like the gaming company that just got lucky, right?
Yeah.
But Jensen's is a smart guy, and Jensen is works very closely with these researchers. If you remember when like OpenAI first launched, and Jensen showed up with that big massive DGX box, and yeah, there was Elon was there and everyone, right? Yeah, back when things were good and stable for OpenAI. So that was a real eye opener. Other things, you you start to learn some of the what's called Jensen math, right? So yeah, Jensen's the CEO of like Nvidia, and they do these tricks. It's sort of related to marketing math. It's like, okay, well, we're going to talk about the number of flops for this chip in and talk about the maximum flops, even though the transformer doesn't actually use that type of like algorithm, right? Like sparsity. Yeah, let's say 2-4 sparsity or something, right? It's not as common in like LLM land as it is maybe in other domains, but we're going to talk about it as though the chip can do, yeah, whatever, 180 like teraflops or something. So
It's like, we just blew that number out of the water. Can you believe how
totally,
good this is now? And
yeah.
then the 2% or 0.02% of people that actually know what's going on, they're like, "So what?"
And what's what's bad about that is you go out and buy this chip and you give them the 70% margin and whatever, and you get this thing installed and you're like, where's my teraflops? What's going on here? And then they're like, oh yeah, that's only under certain condition. The other little sneaky part that like Nvidia has done a couple times in their history, including Blackwell, is they actually end up putting two chips onto
Yeah.
one. And, so I think it's called MCM, multi-chip module something. And so really Blackwell is two smaller Blackwells, and Grace Blackwell is two smaller Blackwells with a Grace CPU. So it's got this like two eyes and a little nose. And they have, super fast interconnects, and they can keep the memory. The memory has to stay coherent. Grace Blackwell, the reason why people either love it or hate it is because the CPU has so much memory. Now you basically have a gigantic pool, like relative to the smaller GPU memory, right? Now you can access the CPU memory. Yeah, it's slower, but I could load more, like parameters. I can load larger things. I can do things. And so when you're, in fact, I just got done working with a company doing performance benchmarks on a Grace Blackwell system, a GB 200. And the calculus, the way that the kernels are written has to change. And so it's not enough to just take your same PyTorch code and run it on a GB 200. Yeah. You have to think
Oh.
about other things, and you have to, and there's there's one other concept, and it's the arithmetic intensity. And that's a property of an algorithm. So that's a property of like the attention like algorithm within transformers, which is really the most critical part, where tokens come in, words come in, and they're then sort of related to each other, and like how much attention are they paying to each other. It's a very expensive computation. It's O n squared roughly, and so if you're not paying attention, and you so that term, the arithmetic intensity, is how much like data movement has to happen per compute. And
Uh-huh.
so, and data movement is actually the slowest part, right? Like moving it from memory into the chip. Like once the data moves into the chip and into the registers, then it can get the full T-flops, right? The full compute. And like compute keeps going up like crazy. It's just memory bandwidth is really the limiting factor. So there's a
Well,
lot
that
more. Mhm.
yeah, that leads nicely into something that you were mentioning before we hit record, which is all of these things that we now have to think about when building platforms for AI, which we didn't necessarily have to when we were just thinking about the CPUs?
These like these GPUs are just little sidecars, to the CPU, right? I mean, that's why they're called accelerators. And that gets to another point where like the more of these accelerators you have, now you've got like bigger problems. And there's the NVL72 Grace Blackwell, which is what a lot of the neoclouds are starting to deploy now, the Lambda Labs, the Verda out of Finland, and CoreWeave and stuff. And that's got 9 trays of 8 of these like GPUs, so that's the 72. And these are all interconnected in a single rack. So that's the beauty of it, is it's a single rack. It uses a crazy amount of power, weighs like 3,000 pounds, which I don't know how many kilograms that is.
It's a lot.
1,500. Yeah.
Yeah.
So yeah, pretty heavy. Requires massive cooling, so, and I guess they're relatively efficient in compared to if you have the same kind of stack or set of servers up and running, but they're beasts that have to be very carefully interconnected. So now we have something that's called the NV link, right? The NVIDIA link.
Yeah.
And one little secret, by the way, that NVIDIA doesn't talk about much, probably because of regulatory concerns, is they acquired a company in 2019. I think it closed in 2020, called Mellanox.
Yeah.
And that's what converted right, like that company into not just a chip company, right? So now we've got like NVIDIA started off just building chips. Now they're an AI systems company. So they've got the switches, the networking switches. They've got like the really fast interconnects, and they just brought in a lot of expertise. That company also that they acquired were the creators, or the most commonly, or I think the most popular like creators of InfiniBand, right? Which is like sort of next generation Ethernet. And so while there's still a lot of data centers out there that are using Ethernet, and you pretty much want to stay away from those, by the way, but you want to stick with InfiniBand. And then if you want, we can kind of get in at some point to some of the cloud providers have their own networking, and so they don't use InfiniBand. Yes, AWS being a very big one, and it always caused problems with us, with customers, because there was an extra layer where we had to adapt, like the NVIDIA libraries had to then work with this custom layer that was called EFA, which required Amazon to then have backward forks of PyTorch, and it was just mess after mess after mess. And that's still with the NVIDIA GPUs. That's not
Yeah.
even getting into Trainium and some
That's
of the
just
custom.
changing one piece
Yeah,
of the puzzle.
yeah, yeah.
Ugh.
And when you don't buy into the NVIDIA like sort of reference architecture, they call it,
Yeah.
which includes all of that, networking, there's a lot of things that you have to do on your own that like NVIDIA is just like, sorry, like we can't help you. So yeah.
Do they void the warranty? Like,
Yeah, right. Yeah.
that's
And that's something
it's
else
so
too.
brutal.
Actually, good segue. These chips, I don't know how familiar you are with the failure rates of these GPUs. I mean,
Yeah.
yeah,
And
these
that was
things
kinda
run.
I wanted to ask you about the reliability in that regard because I've heard from all different areas on how unreliable they are. Just
Yeah,
the
it's
chips
amazing.
themselves, but then also everything that comes around the data center and not having power to 1/4 of the whole data center, and it's going out, and so you have to have all of these extra fail-safe modes because you basically have to expect that things are gonna get switched off.
Hmm. Hmm.
And so the chips themselves are very unreliable, and then you're talking about, like, just chips blowing up or chips basically being rendered not usable?
Yeah. every single cluster that I get on, like a new cluster, the first thing I do is put it through sort of I just, you know, put the pedal to the metal, yeah, as they say, and figure out like which ones are on the verge of burning out. And I'll burn out 2% just within a
Wow.
couple, minutes, because they're purposely designed to run hot, which is
Uh-huh.
why they need a lot of cooling. Even, yeah, I don't have one here, but those little small DGX sparks that they came out with, if you've ever run like something on there, like, I mean, that thing can burn a child, right? It's not safe to have in your home. Like, I don't think it's gonna burn down a house or anything, but it's gonna burn your skin. And that's one, Blackwell. It's a Grace Blackwell. But and that's also why that particular machine is a little bit constrained. They don't have certain instructions for some of the tensor cores and things because they physically can't keep it cool enough in a consumer device, right? So it's not really the best device to learn like real CUDA programming on. But yeah, they'll burn out. They throttle super quickly. So when you're doing any kind of benchmarking, what you're supposed to do is lock the clock speed, the like GPU speed, so it doesn't get up above a certain temperature. Because yeah, otherwise at any given point in time, they're being throttled so that they don't burn out.
And you're talking even the new ones, right?
Yeah. Oh yeah, especially the new ones. Yeah,
Oh, yeah. Because I think I heard somewhere where there's, like, a warm-up period that you have to go through in order to know, like, is this gonna go or not?
for sure. Yeah, yeah, that's what I was referencing to see. Because they all, that's another thing that you realize when you start thinking about hardware and reading about the failure rates and the fabs and how they're designed. Like at the end of the day of the day, they're still manufacturing like defects, right, that are
Yeah.
happening. And of course, they're generating millions of these chips. They're, building millions of these per year, and they have to be at a specific temperature, which is why the Arizona fabs have always been a little bit controversial because,
So
um,
hot.
yeah, it's hot. There's no water. I mean, you're in the
Yeah.
desert, right? And even if you do like get through all that, even even the ambient air being different than what like Taiwan Semiconductor has in, like Taiwan, it's just a different climate, just a different thing. And if any of those are different than what they expected, they have to then go through and add extra filters or do something with the air. So yeah, there's a lot going on
Why
with these things.
did
Mhm.
you uncover why they're so finicky? Like, why can't they make them so it's less precious and just,
Yeah,
like, battle hardened?
yeah. Well, part of it is right. Like, do you remember when you maybe built your first computer, or your friend built his first computer, and you found out you can overclock the GPU or the CPU or something, and
Yeah.
you're like, why the hell would I not overclock this? This is obviously I'm going to do this, right? And then you do it, and then you realize, okay, it burned out. Now I got to go back to Fry's or Micro Center or whatever, Best Buy, and get a new, chip. So part of it is they're optimizing for performance, right? And they, but even separate from that, there's just at scale, there's just going to be like, like molecular issues, right? And so the best thing you can do, because I'm given like new clusters all the time to say, hey, help us tune this thing. And so that's the warm up period, is like really figuring out. And in a cloud type of environments, I hammer those things because I'm like, you guys should have already warmed this up. Now
Oh,
it's my
man.
turn from the sort of application level to make sure that my application, that my workload, and then it. I would say probably 60% of the time, 60 to 70% of the time, they have to spin up a new cluster because something went wrong. Yeah. And there's entire products like SageMaker HyperPod was built specifically to have a a standby, like a warm standby of GPUs that have been pre-warmed up that can
Oh.
be swapped in. Um, that's the whole premise of the product. Yeah.
Well, you were also talking about an ABD type of product, but for GPUs that from the
Yeah.
tell me more about that.
Yeah, so for listeners that might not be familiar, AppDynamics is a company. They're relatively old right now. They were new when I joined Netflix, and that was I think 2011.
Uh-huh.
Um, and AppDynamics was think of it like an agent, not the current definition, yeah, of an agent, but like think of it like right, like a daemon thread, or a process that runs on all of your servers. So back then, Netflix, it was all Java based streaming servers, and you know they could, each of those processes that were running were very very like lightweight, but they could um, track all of the like network traffic, so we knew which of our, because like we had hundreds of these microservices. It was very much inspired by like Amazon and Bezos and the microservice. And so just trying to even get an understanding of how our services were all connecting to each other and the health, that was a big win. But it also tracked the memory, it tracked any sort of oddities going on. This was all CPU based. And so there's this company that I met actually because of the book that's called Zymtrace, ZYM Trace. They're actually based out of London.
Nice.
And they are ex like AppDynamics people, right? Which is why I was very interested in them. And they remember when Netflix was their first customer, and so add in all of the similar things that AppDynamics did, um, but then also now add on all this complexity about the like GPU power, the GPU temperature, any like they can detect when a GPU is being underutilized, and they can make suggestions at the full system level, and say, hey, maybe, and they're very much like, right, like LLM aware of,
Mm.
yeah, this product, and so it can actually look at your training workload or your inference workload and say, hey, it looks like you need to add a few more like experts in your mixture of experts model over here, and on this server is underutilized, or the networking's not optimized for, yeah, for this particular setup. Yep.
Going back to when you're warming up these GPU clusters, this is primarily with you running inference loads, right? It's not for training.
Yeah, I do both. I mean, it depends on, and keep in mind RL, right? This is kind of the dirty little secret, is that it's both, right? It's doing inference, and it's doing backprop and updating weights and things. So, but interesting that you say that, because HyperPod was actually built for training.
Uh-huh.
Um, and the ability to, if a GPU or like an instance dies, we have this warm standby that can come in, and the job can then continue without this like major, job restart where you might lose the last couple hours because your last checkpoint was a couple hours ago and things.
Yeah.
So, and then very quickly, customers were like, "Hey, we actually want to do like, right, like inference on this thing. Either we're generating synthetic data for the next training run, or we're doing RL, where we have to do a bunch of inference and then compare it to the, or like verify it, right, in an RL." In an RLVR, right, where you're doing reinforcement learning with verifiable rewards, where you're, either like executing code, or you're doing math equations, or you're running some kind of experiment. Yep. And then verifying it.
So you undoubtedly have looked at or have a good pulse of what's on the market for whether that is the Lambda Labs of the world where you can get down into the bare metal and kind of control everything from what I understand, or it's the base 10s where it is straight like, hey, just throw whatever you want and we'll give you this API. Uh, are there any that, or do you have any commentary on what's out there right now?
Yeah, sure. Yeah. And obviously, as we've seen over the years, all of these companies end up looking like that, yeah, over the years, they all start to build each other's features.
Yeah.
So
They're
I
all
would
the same.
argue,
Yeah.
yeah, well, you start off with one set of skills, get a little success, and then customers start to ask for more and more and more. Perfect, perfect example here would be Lambda Labs, actually. Lambda was primarily training. They started to dabble a bit into inference. They even had their own chat, like Lambda chat or something
Yeah.
at some point, which I didn't really use that much. But it's very obvious when you see their roadmap about which kind of customers that they're now starting to get. Like the first initial tranche, might have been like the big labs, right? I don't know for sure, but um, and and then to contrast, folks like Base 10 and Together and Fireworks, like those folks, they were just trying to get the open source models out, like behind
Yep.
an endpoint, maybe supporting fine tuning so that you can customize the open source models. Very different model, right? The labs, or sorry, places like Lambda Labs and CoreWeave, they're there to customize and pre-train and do the full training lifecycle. But they're realizing that because inference is like a major, these apps are running 24/7, right? People are like asking questions 24/7, that they have to get their like inference act together. Yep.
Uh, Yeah, it's fascinating to me to think about how that idea of everyone converging, and I do think that we'll see that. It's cool to see some of uh, the different ones stay in their lane or just say like, "Hey, we're just gonna do this, and that's all that matters." And then others are trying to go and be the whole platform. And I do appreciate that you have so much variety right now in the way that, like, the value prop of modal is you can get these GPUs going really fast. You've got that cold start, or it gets going and you're good. One thing that is wild to me, though, is that they're all running on top of other people's hardware.
Yeah. Yeah.
They're just renting out GPUs from the other people that are potentially competitors.
Right. And they're able to aggregate that demand, because yeah, I don't know when the last time you've tried to go in and like rent a B200 from AWS, but you can't do it.
Impossible.
It's
Yeah.
impossible. And CoreWeave laughed at me. I literally, during the development of the book, I said, hey guys, I'm writing a book. I'm a third time author. I'm would love to mention you guys in the book, which I still do. I'm not like a dick or whatever, but they're like, we literally have no capacity, and the minimum spend is blah blah blah, and so like they didn't laugh at me; they were laughing with me, because I was like, yeah, I came from Amazon, I get it, but I just yeah, thought I would try, um, and they they're booked out, like, yeah, when I spoke to them over the summer, they were booked out for like 2 years, and they just can't even get enough, and then there's the issue of, even if they could get enough, where are they gonna get the power, and how do
Yeah.
they, all these turbines, and, I guess the turbine blades are the most precious, like,
I
you can build a
heard that.
turbine, but
Yeah,
you
I
can't.
heard that recently on, the Stripe podcast.
Oh, interesting.
It
Yeah.
it was exactly that, talking about how the blades are not being made fast enough.
Yeah,
And
which
I
is
think
interesting.
they're coming from I'm in Germany right now, and I think I remember hearing that it was coming from Germany, and it's like, "Hey, somebody needs to put some, light a
Yeah.
fire under the German's ass."
Fuel on the fire, yeah.
Yeah. What's going on?
Yeah.
That is it is wild. And, how much did you research or decide not to research on the alternatives? Because like, AWS has Trainium, right, and Inferentia, and then you've got TPUs, and you've got AMD. There's lots out there, but, like, a very small subset of the users actually use that.
Yep. And that's the answer to the question right there, right? Is, you know, this book was supposed to be 300 pages, and when I got as deep as I did, I said, "It will be a disservice to the folks that read this if
Wow.
I don't cover, like, all of CUDA," right?
Totally.
That makes sense for this domain. There's still so much more to CUDA, and there's still, so much more, and all the texture renderers and things that are actually, still used as different types of caches and stuff that have wonky names that don't really translate to the LLM world. So, but there's so many patterns that have been built up that are, and if you take something like flash attention, you know, um, that was built by the chief research scientist over at Together AI, right? He's a famous
Uh-huh.
guy, Tree
Tree
Dow.
DAO, yeah.
Yeah, he's pretty badass. He really brought light to this like mechanical sympathy type of thing, and the big revelation is let's use the fastest memory for the things that need to move. The like memory that's closest to the chip. Let's put things that are constantly moving in and out. Let's keep it there so that doesn't have to travel across all the other slower, bandwidth like interconnects and just that one small change made huge performance gains. And that's why with every generation, flash attention has to get rebuilt and reoptimized because it's not fully taking advantage. And there's a flash attention 4 or maybe it's up to 5. I think 4 is the Blackwell version basically. So the short answer to your question is there's so many patterns that fit the goal of my book, which was this co-design just within like the Nvidia ecosystem. And it really, really covered everything that I wanted to cover. So not only is it the most widely used chip, but it's also the most widely uh, the like supported. There's a lot of community support. There's people that have figured out the like you can infer the crappy documentation from all of the examples that are out there. And that's not the case with AMD. That's not the case with Trainium. It's really hard to understand these chips without having someone from AMD or someone from Amazon right next to your terminal, helping you code it. So, and it just would have exploded the book. I mean, then the book went from 300 pages to 1,000, and then, but during reviews, people kept asking, why aren't you talking about Trainium? And
Yeah.
my funny answer
TPUs.
was, yeah, and TPUs. Actually, I probably would have talked about TPUs even over Trainium, just because it's a different type of architecture and systolic arrays um, and uh, but you know we we didn't have a lot of customers using Trainium back then. Yeah, obviously, yeah, Anthropic was basically forced to use right because of the partnership. Um,
Uh,
and
against their will, yeah.
Yeah, and well, no, I mean, they've been pretty successful. It just took a lot of work, and price performance, was good, and they're trying to keep costs low and stuff. Um, and just having other alternatives. I mean, I saw this back at like Netflix too with the cloud vendor. Netflix famously chose Amazon, right, like AWS as the cloud vendor, but we always teased them to say that we were going to go to Azure or to GCP when at least back then there was no way in hell we were switching off. It was going to take too much effort, and like we had features to build, right? Like
Yeah.
yeah, these days Netflix is in kind of a maintenance mode is what I've heard. I haven't worked there in 15 years, but um you know so now they could take on projects like that. But yeah, back then, we were building streaming while we were, scaling onto AWS. So just having that sort of threat of being able to switch, which is what Sam Altman's doing right now, right? He's got
Yeah.
Cerebrus and he's got yeah.
How much have you tried to play with coding agents, like, at this level?
Yeah, 100%. I'm actually tuning a kernel right here, right behind your screen. It's very different than generating a Next.js app.
Or
There's
my
not
local app that I was telling you about in the beginning.
right. Yeah, single use, bespoke throwaway app.
Yeah.
It's, and halfway through writing my book, the other reason why I insisted on it being as big as it is I selfishly wanted to use it with my coding assistant. So about July last year, I was asked to cut a lot of this book because it just got massive. We were either going to split it into 3 books. It's really
Wow.
3 books in one. It's like kind of a systems like OS Kubernetes, like optimization for AI and storage, and then it's like CUDA and all the crazy things there to support the LLMs, and then it's inference and training, and it's kind of systems wide. And they so we were going to do a 3-part thing, and then I just couldn't take it anymore. I just had to get these words out, and
That's
and
funny.
I had other
There's a
shit to do,
saying
right?
in my old producer when I was making music would tell me, he was like, "You don't finish an album, you abandon it."
No, that's right. Yeah, yeah, yeah.
So that was what you hit. But sorry, I cut you off. You were saying that there was that moment.
There was a moment when I was like this book is going to be good for the readers, but this book is going to be even more valuable to the like to the agents, right? To the coding assistants. And it has saved me so many times because these models the lack in certain domains, right? There's just not enough training data, for example, on how to tune kernels and how to optimize CUDA. It's in a lot of engineers' heads that work in Santa Clara at the Nvidia office, but it's not because the code's not open source, right? There's a lot of code within their ecosystem that's hidden.
Mm.
And it's all C++, and it's all shipped as binaries and assembly, and yeah, good luck trying to reverse engineer some of that stuff, right? So my goal was to, if I was going to continue down this route and let others explore this route, I really wanted to make the book more of a flywheel, and that's why the GitHub repo is so critical.
Oh,
And
yeah.
I've built a bunch of MCP tools that are, of course, very friendly. I now have OpenClaw. Yeah, I had to jump on OpenClaw, so
Nice.
I've got like a GPU claw,
Oh,
or yeah, yeah. I keep like renaming it, right? Just like OpenClaw. Yeah, I've like renamed it about 3 or 4 times, but really, it's a sort of AI systems optimizer skill, and it can go out there and run all the cluster checks and try out the different things and make sure all the tensor cores are working as they should be and stuff, right? Because
wow.
that's the key. In CPU land, we've got instruction pipelines, right? And some of them are instructions to load memory, instructions to do, but they're like fairly general and basic. On a GPU, there's pipelines to do crazy, crazy shit. There's even special memory that's called tensor memory that works with the tensor cores. So tensor cores are like segmented off separate from the CUDA cores, the sort of generic, CUDA cores. And they're typically designed for specific precisions like floating point 16 or FP4, and so when you're writing a kernel, you have to know that there are separate pipelines for these things so that you can write them in parallel and say, okay, while you're computing the results in FP8, I want you to go do the multiplication or for the first instruct, because you're like constantly overlapping, right?
Yep.
That way you can hide the relatively long time that it takes to move the data in from memory in. And so now it's a trick of trying to take advantage of those parallel pipelines. And yeah, Blackwell did something sneaky, by the way, when they moved from Hopper to Blackwell that like not a lot of people know about, where they got rid of one pipeline and put it towards another. yeah, basically said, okay, it seems like these days no one's really using, int 8 or something, or FP64. So
Yeah.
yeah, we're going to actually take transistors away, resources from that particular use case and put them towards. And if you don't know that, and you've got code that's relying on that, you're going to run on Blackwell and see a huge performance hit and be like, yeah, what the f? So
Yeah, I thought this was supposed to be better.
yeah, yeah, right.
Oh, man. And so have you just created, like you said, skills for them that you've thrown on the GitHub repo? Or is it that you're using, some kind of a RAG on the book?
Right. Of course, back when RAG was big, that was in my head. These days, I just rely on cursors like grep and rgrep, and
Yeah,
so yeah, I've
nice.
converted the book into Markdown, and it's by chapter, and I've got
Oh, that's
all of the
awesome.
examples also by chapter, and so I can usually hint, to cursor and like put the chapter that I know is relevant to this particular task that I'm working on, just to kind of minimize it so it's a little bit faster. But and this gets in this might be a good segue to the controversial Codex versus Claude. So
Uh-huh.
yeah, curious what your go-to is these days. Is it
I
Opus 4.6?
so I use Opus 4.6. I have heard from friends. I just haven't given Codex enough time. And I will also use Gemini and then anti-gravity, which sometimes completely bricks out my computer. So like it's so heavy, it's just like, what is going
Yeah,
on here?
yeah,
But that's a whole nother story. And I haven't given Codex enough time. I have friends that have said they prefer it. It's the best because it doesn't take as many shortcuts, all of that stuff. But I'm like, dude, uh, I'm already paying Anthropic so
I know.
much every month that I'm cool just sticking with it. It's good enough.
It's good enough. Yeah, yeah, yeah. I was once like you. Yeah, for sure.
You've you've changed?
I
You
yes. I I used Claude Code like initially because of the hype and because I just and trying like Codex is relatively new, compared to Claude Code. Maybe it came out a couple months later, so obviously for but what I noticed, especially with larger code bases, there's almost 1,000 samples in my GitHub repo for the book, and I've noticed, yeah, I think shortcuts is probably a good way to put it, where it's not reading all the files.
Yeah.
Claude, like Codex is way slower. Yeah, obviously way
Uh,
slower, which is why I was excited about the Cerebrus version, the Codex Spark. I have thoughts on that. I still stick with the slower one.
oh, yeah.
Yeah, um, but I I can step up and walk away and go to the gym or go do something to the store, come back, and I know Codex will have
Got it
completed the
done.
task.
Yeah.
With Claude, I feel like it's designed for a different type of user who is sitting there waiting and wants to see and wants to be part of the solution. Yeah, do you feel
There's a
that way?
little more back and forth. I
Yeah,
will notice that, yeah, it hardly ever gets it the first time. And so you have to go and you have to manually validate and then be like, "Oh, I'm getting this error, or, something this isn't working, check that." And, uh, I could see that. Alright, well, shoot, like, I needed another freaking subscription in my life.
yeah.
I guess I'm gonna have
And
to go now and do it.
I mean, I think that's where the Ralph Wiggum stuff
Yeah.
comes from, right? Like putting it in a loop. Like I just thought that was so ridiculous. I'm like, yes, I love Ralph. Yeah, obviously my favorite character on that show. But I don't need him in my development cycle. I just want the model to do it. Now the other thing too is that it appears that the way that Codex has been post trained, it is doing more frequent like compactions, and it's doing
Oh,
it in the model, where it seems like Anthropic post training has it kind of only when it gets full, Whereas, Codex kind of does it when it determines that it's a good time that it can compact things and not lose too much, versus a huge context. Okay, now I'm at 70% or 65%. Now I'm going to compact. So, um,
Yeah, actually, a lot of times the best performance gains you can get are just by clearing that context window.
mhm,
And then it's like, wow, the problem that I was having, it just miraculously disappeared.
yeah, it's counterintuitive because you
Uh-huh.
want it to like remember all of the mistakes that it made or whatnot. But yeah, if you
Yeah, it
give it a
figures it out. For
clean
the
slate.
skills piece, you know what other one that I've been loving? It's called, I think it's called like Claudeception. Have you heard of that one? Where
Uh-uh.
it creates skills when it goes through and it does something, it will then reflect back and be like, could I have made a skill out of this? And then
That's
it will create its
exactly
own
what
skills.
I've been looking for. Oh, that's
There you go.
crazy. Okay,
Yeah.
because I do that manually.
Yeah.
Like,
I figured when you were saying, "Oh, well, yeah, I will go and create some skills if it's there and I see that it's needed." But yeah, try Claudeception out, see if it works. And there's other ones that have been very useful too. My friend Raul was telling me he just creates one skill and he spends a lot of time teaching that one skill how to then create all the other skills. So if he ever says, okay, go make a skill out of this, it knows what to do.
cool. Okay. Yeah. Yeah, that's a cool pattern. Yes, I love these discussions because everyone has their own workflow
Yeah. That's
um
what we started doing because there's just basically there's 100,000, 200, 2,000,000. I don't know how many people now are their own little R&D department. And we've all been empowered with, "Hey, just go try stuff." And so we get together on Fridays now and have little lunch and learns and be like, "What are you doing with it?" "Well, oh, really? Oh, that's interesting." And we've had some folks come with ideas of, "Well, in human psychology, we
Right.
can't really understand 7 layers deep.
Oh, I love it.
We can't go past 7 layers, so anytime we get I create a file structure, I never wanna go past 7 layers for
Uh-huh.
the LLM, and it's like, dude, I have no idea if that works, but just the fact that you're trying it is really cool to me.
Yeah, when do you run these? This is a
On
formal thing?
Fridays. Yeah, yeah, I'll invite you to 'em on
Oh,
Fridays
please.
at lunchtime in California, so around 11 AM, yeah.
Nice. Yeah, man.
Yeah,
That's
it's
super.
fun.
Yeah, in fact, do you know Swix? The
Yeah, of
yeah.
course.
I was chatting with him at the like Claw conference. Yeah, do you remember the ClawCon that
The
happened?
clock on, yeah,
Dude,
so
that was
fast.
a shit show. It was an
What?
absolute shit show. Yeah,
Oh, man, a
in like a good
bummer.
way.
Yeah.
Like a San Francisco's back like kind of way, right? People had like lobster. They were serving crab
Claude.
legs
Yeah.
and just chaos. Yeah. Um, but I was talking with Swix and we were chatting a little bit about making that like a first class track in his like upcoming AI engineer summits because and just having people, yeah, even if it's informal, maybe like a lunch where everyone comes, gets together and shares, but I think that's super powerful. Yeah. Yeah, when did you start that?
Just recently, because we did a reading group in January, our first reading group of the year, it was on vibe coding, and then we read the paper, which was cool for the first 15 minutes, and then it just devolved into everybody sharing
I do
how
this.
they've
I
been
do, yeah,
getting a little bit more gain, and that was like, "Wow, well, we should do this again. Let's make it a thing." And so we started doing it on Fridays, and it's been so useful to me, and especially because maybe I'll know about this, but then somebody else knows about that, and I'll say, "Oh, yeah, but did you try Claudeception?" And they're like, "Well, no, actually, I like, this
right.
one better." And it's the community Slack is great for that too, but when you are actually prodding and probing a little bit more, then you get different ideas out of folks.
Totally. Yeah, great idea. I'm gonna clear my calendar for that one.
There you
Yeah,
go. Well,
that's
yeah,
working.
and actually, now that you say that, we're doing the coding agent conference on March 3rd, right? And one idea that I had for that was exactly what Swix is thinking on. We need some kind of unconferencey way to let people just give their best tips. And I landed upon, we're gonna do a session where we'll just have a Slido up and people go to the Slido and then they put in Slido what their best trick is. And then whoever like what gets upvoted the most, that person gets to come up on stage and then demo
Demo
that
it.
and showcase it. So that's one of the
Sweet.
things that we're doing. Yeah. And then I'm also going to do that kind of thing with hot takes. Like, what's your hottest take? And then whichever ones get upvoted the most, they come on stage and have to defend their hot take.
You know, I think the biggest hot take from the Peter Steinberger, the OpenClaw guy, right?
The whole journey.
The journey, yeah, he was. It was very clear from his Lex Friedman interview. From he was at the ClawCon, of course. Yeah, I mean, he was talking trash about everything. Yeah, he said something, and this is all public. You can go watch the video, but he was joking that he was reached out by so many folks. He got an email from Nvidia, like not Jensen directly, but some whatever, like lieutenant of Jensen's, and they sent him a Microsoft Teams invite, and he just rejected it because of that, and said, "I'm not going to work with you guys because you use Teams."
No way.
Yeah. So I mean, he's a really interesting character in that, like, he just doesn't give an F.
Yeah.
He
He's
seems.
got enough money to not care, right? So I guess
Yeah,
that
which I didn't really like. I knew nothing about this guy until
me neither.
OpenClaw. Yeah,
Yeah.
but
Yeah, I think a lot of folks had no idea who he was or what he was doing. I just love the fact that he shipped like 40 products before OpenClaw took off.
totally. Oh,
It's
right,
like
right.
that's awesome to see. I also just found out that he is absolutely jacked and like
Really?
might be on steroids. Yeah.
I mean, yeah, yeah. He's a big dude, I guess, in person. Yeah, I mean, he's like Austrian, so
Yeah.
yeah, he's got
So
those.
is it steroids or is it Austrian? I don't know. Arnold
Yeah,
Schwarzenegger,
yeah, he's got
also
the Schwarzenegger kind
Austrian.
of.
Oh, that's hilarious. And
Yeah. Did you listen to the Friedman podcast?
no, and
Yeah,
is it worth it?
it's like 9 hours or 4 hours or
Yeah,
something. But Friedman's
typical.
good now about doing clips, and so
Uh-huh.
you could see. But yeah, Friedman kept pushing him on which direction are you going. Oh yeah, and then this is what I was going to say. I was surprised. He's pretty anti-anthropic. Everything from, I mean, besides the little mini cease and desist on the name,
Yeah.
he was not impressed. It didn't make the top two. The top two that he told Lex about were either Meta, because Zuckerberg actually pinged him on WhatsApp directly and was
Wow.
asking him questions about the API and how it was designed, and said he was actually building something and he wanted to talk to him. And so, and he liked Sam Altman. He made a comment and said, a lot of people vilify those guys, but honestly, they're hackers like us, right? So just in different leadership types of positions. But yeah, Anthropic, and basically he's a Codex user. So,
Uh,
and he was describing very similar things to what you and I are mentioning, where it's like there's too much back and forth. There's too many decisions that I need to make that I would expect the model to make, and I just
yeah.
want to fire off 15 of these things and know that it's going to get it done. Yeah.
Oh man. No, I gotta go try it. No, I gotta go have some fun with
200
Codex. All right.
bucks.
Yeah,
200.
I'm gonna go and do that right now. Shoot.
Yeah.
The
What's your biggest like monthly bill for Claude or for any of these?
I probably so I am relatively again, I'm just building for myself, right? So I'm relatively calm, but I probably spent like 340, which can be a lot or it can be nothing depending on who I'm talking to.
That's
Uh,
nothing. Yeah.
yeah.
Yeah, that's just me
Exactly.
getting my, yeah, just
Warming
getting
up
the
those clusters, huh?
totally.
That's
No, they go by quickly. I think from what I hear at meetups, I think 1,500 to 2,000 per month seems to
it's
be.
pretty standard.
Yeah, some people hit 25, 3, but yeah,
Yeah.
I can burn through like 2,000 without even thinking about it, and then I have to,
Wow.
set up alerts and be like, oh crap, I
Yeah.
have to make sure I can pay my rent. So
Yeah. Oh, that's classic. And so talk to me how you're using these for the kernel exactly. I mean, you're doing the skills like you mentioned, but what other stuff are you doing spending all this money?
one of the issues, if I get a cluster with a new chip, so let's take the AMD or the newest versions of Trainium, which I didn't have any exposure to before I left Amazon, so they're pretty new to me. You have to like really dig deep. You have to look at like take a really fast library, like in the Nvidia world that would be cuBLAS, right, which is like highly tuned by the CUDA ninjas, and it's like this badge of honor that you can get it to. And so um, doing something like that for these other chips and looking at the assembly, and these models are not good with assembly, but they're good at reading text. I mean, if it's like genomic text or strings, and and can build patterns. And so I've developed some ways to like reverse engineer, and like this is all brand new stuff that I've been working on since I finished the book and finally had time to explore. But really, that's outside of having one of these CUDA engineers next to you, or these hardware folks next to you. That's really the only other way to do it, is to take these non-public frameworks, have them compile the code, and then just try to decompile, and yeah, just basically like reverse engineer, and then try to apply it to other use cases. So
Wow.
yeah, um, and that then leads to different types of like innovations with flash attention, and the deep seek moment where they found something that was in the assembly, and then they had to reverse, and fortunately, you know the instructions kind of give you a hint as to what they are. Like if it's something .l2, like it's doing something or bypassing or something with the L2 cache. And so you
Uh,
can play with that, and you can pull it out, you can put it in, you could double it, you could, do it twice, you can do it and see what's actually going on. So it's right now it's a game of just let's just try to figure these things out, because even, the Nvidia folks aren't always optimizing for your use case.
used to. Yeah.
I mean, fortunately, they have a lot of resources now on right, like LLMs and things, but even like 1 or 2 years ago, yeah, it wasn't this case. But there's not enough training data. And I think when these labs go to do their next round of RL, or their next round of pre-training. Let's start with pre-training. Trying to get in these long reasoning chains, which I'm generating right now. Like it's trying different things. It's like exploring. So actually, this like leads to kind of a more general pain point that I see when I'm using these models is, yes, I could read snippets of the reasoning chains, the thinking,
Yeah. But you
but
can't see all of it.
yeah, and I feel like, heck, we're paying for it. I mean, that's 90% of my, like $2,000 bill is the stuff that I can't see, right? And so I actually want to get a way to pull that in. So I
That's so
think you
true.
can. I think with the API, I think you can get more
Yeah,
more detail.
I also had this guy Rohit on here probably 7, 8 months ago now, and he said something beautiful that I still can't do, but you can kind of hack it together, which is he's like, "Why can't we have different situations where if I want to go through and figure something out during that reasoning process, I can nudge it one way or the other. And so now I think you can kind of do that with just interrupting it and then
Yeah.
saying, go here and go
Steer.
there. But the problem is if you don't see the reasoning happening as much as you would like, then you can't steer it.
Yeah. Yeah. Or it's mid steer already,
Yeah.
and you're because that actually happened to me last night. I was trying to steer it, and or by the time I see it, it's already
Too late.
too late, right? And so yeah, a little confusion around that kind of stuff. But I mean, I'm thinking of this in the fact that I'm burning tokens to get to an answer that I want to make sure I get the answer a lot faster next time, right? And it's like, how do I do that? I can do the thing, where it's going to create a skill, like you were saying, kind of dynamically, or I can have it update the agent's MD or the Claude MD to remember something about that. But I still think there's a case when, and so the point that I was going to make was I also met this other company, actually several companies, but one company in particular out of New York that is building their own sort of reasoning chains for CUDA kernel optimizations.
Oh,
And that got
nice.
the attention, of course, of of the big labs, right? They like very much, have an interest in making their models better at doing this because it's going to make their jobs much easier. Also, too, because OpenAI, for example, hasn't quite made the shift to Blackwell, or last I heard, they were still, and like you can tell because they created this language called Triton. So Triton is like a little, and yeah, so I cover Triton in the book, I think chapters 12 and 13 or something. Triton is like abstracts you from having to write CUDA, and it's in Python, and it's its own DSL, Python-based DSL, and it gives you access to CUDA-like constructs, but at kind of a higher level of abstraction. And those libraries are not optimized for Blackwell, and
Uh,
it's because like OpenAI hasn't gotten there yet, so they're not spending any resources. So you can kind of back into where they're at in their hardware stack by how much they're supporting the software that they have open sourced. I mean, they might have an internal fork that they're not sharing publicly, but
yeah.
yeah. So, but so these companies that are tuning all day and have huge clusters and trying out different experiments to get the best speed under sort of LLM, like token generation use cases, they're they're sharing this data with the labs,
Uh-huh.
which when I talk to them, I say, don't do that. Like, why are you doing that? Right?
Oh,
Because
really?
that's, well, that's
They should
like,
sell the data. Don't
y-
share.
yeah. And, quite honestly, maybe they are selling it and they're not telling me or something, but it sounded to me like they're trying to get in with the labs. So they're just going to give it to them for free. And I'm like, dude, like that's your, that's, your moat,
Yeah, exactly. That's
Um,
basically you're shooting yourself in the foot there.
yeah, potentially. So not unless there's some other arrangement. Yeah, they're also doing it with like AMD. They're also doing it with these sort of newer chip companies. Yeah, yeah,
Have you thought about open sourcing your different conversations or reasoning paths for stuff that you've been doing? Because it could potentially be training data there too, right?
yeah. But like that's what I'm saying is I have to get this data, and I don't know how to get it from OpenAI. Right?
Huh. Yeah.
If if I was using the API, maybe, but I use my subscription
Yeah.
through. There's like two different ways to authenticate. You could use the API key, or you could use But but yeah, that's exactly what I'm saying is like I don't know if like anyone else has like thought of this, but we should have access to these tokens. It
Especially if you're
We're paying for them.
creating such high valuable data.
Yeah, right. Well, OpenAI very likely has access to
Yeah.
these. So
If
now it's
they I wonder what the chances are of them actually
Right.
knowing that this is being created and this is valuable. It reminds me of back in the day, I heard a story that if you Googled something about some really fancy algorithm, then you would get a call and it would be like, hey, come work for us. Because there was
From
only like,
yeah, from
yeah,
Google.
from Google. It was something around, I think it was a search algorithm or something where
Yeah, yeah,
you were
yeah.
like, oh, if you know about this, you've gotten this far, then you're legit and you should come and work for us.
Hilarious.
So
Hilarious.
it's like that. Are they, do they know that the data chain that you have going on is that valuable? I wonder.
I mean, they certainly can.
They can find it.
Yeah, yeah, of
Yeah.
course.
We're telling them right now. We're making it very clear. If anybody at the labs is listening, go and look at, if anybody at OpenAI specifically, yeah, it's like,
Right now,
go,
9:38 in the morning. Yeah, with
yeah.
PT.
You're tuning kernels. That's some sweet stuff.